sketch of the region represented by the definite integral 0 to 2 square root of 4x minus x squared dx, and then use geometry to evaluate the area. So let's take a look. First, I'm going to sketch this. So I need to know what the curve looks like inside of the definite integral. So I want to know what does f of x equal to square root of 4x minus x squared look like. We could try to apply methods of calculus, first and second derivative, but much more elementary methods are going to get us through here. So I just let this be equal to y, square both sides, and then we notice this is shaping up to look like a circle. I push everything to one side. I get y squared plus x squared minus 4x equals 0. So we can clean this bit up here just by completing the square. So remember the rule for completing the square. I'm going to take x squared plus 2ax, and then the rule is x plus a squared minus a squared. So here, a is minus 2. Okay, I'm just going to take half of the number that's in front of the x. So we're looking at x minus 2 squared minus 2 squared, so minus 4. Okay, be careful. Just because I have a minus 2, when I square it, that becomes a 4. This thing in the back is always going to be minus a number. Doesn't matter if you're starting out with a positive or negative a. Now I push the 4 over, and now I'm looking at the circle. X minus 2 squared plus y squared equals 4. So we have a circle, the center, 2, 0, and radius equal to 2. So we can sketch the graph. Notice we're only taking the top because we have the square root. Square root only returns positive values. Positive values coming out of a function means you're only above the x-axis. If I look at the definite integral, we're only taking the limits from 0 to 2. So I only care about the region above the interval 0 to 2. So what we're looking at is 1/4 of this circle. Okay, so to get the area, I'm going to take the area of the circle, divide by 4. The area is pi 2 squared, so it's 4 pi divided by 4, or our area is equal to pi.